The Earth is wrapped in a silence deeper than death, a silence so complete, it feels like time itself has stopped. The sky, once painted with golden sunrises, is now a wall of ash. No birds, no breeze, no light. Forests that once echoed with the songs of life are nothing but blackened skeletons of trees. Day and night blur into one endless twilight, the sun reduced to a dim, cold memory behind the dust. From beneath the charred earth, a small creature emerges, barely 6 inches long, fur singed, eyes alert. She is not strong, she is not fast, but she is alive, and that changes everything. This is not the story of the great beasts who once ruled the world. Their bones lie scattered, their reign reduced to fossils. This is the story of those who endured, of the forgotten survivors, of the meek who would inherit the earth. When the asteroid struck, it didn't just wipe out the dominant species, it shattered the rules of survival. Power meant nothing, only adaptability did. And in that single, terrifying moment in history, the story of humanity began, not with kings or conquerors, but with a tiny, overlooked creature in the shadows. This is not just a story of extinction, it's the origin of us. Chapter 1. When the world burned 66 million years ago, the Earth was a paradise dominated by colossal creatures that had ruled for over 160 million years. The dinosaurs. Thick, humid jungles teemed with life. Oceans churned with marine reptiles the size of buses, and the skies were patrolled by pterosaurs with wingspans broader than fighter jets. But in a single moment, everything changed. A 6-mile-wide asteroid, moving faster than 20 times the speed of sound, slammed into the Yucatan Peninsula of what is now Mexico. The impact released energy equivalent to billions of nuclear bombs, vaporizing rock and ocean in a split second. A crater 110 miles wide and 20 miles deep opened in the Earth's crust, today known as the Chicxulub crater. The surrounding sky ignited instantly. Wildfires erupted across continents. Trees exploded into flames. As debris from the impact shot into the upper atmosphere, it rained molten glass for hours, setting the world ablaze. The intense heat didn't stop there. A global heat pulse followed. Temperatures soared above 1,000 degrees Celsius for minutes, incinerating anything not shielded underground or underwater. Then came the darkness. Ash, soot, and vaporized rock clouded the atmosphere, blocking sunlight for months, perhaps years. This impact winter plummeted temperatures, halted photosynthesis, and caused a catastrophic collapse of ecosystems. Without sunlight, plants withered and died. Without plants, herbivores starved. Without herbivores, carnivores followed. The once vibrant, thundering Earth grew silent. The food web unraveled with ruthless efficiency. Scientists estimate that 75% of all species vanished. Not just dinosaurs, but also marine reptiles, flying reptiles, and nearly all plankton, the very foundation of ocean life. Fossil records from around the globe, from Montana to Morocco, from New Zealand to North Dakota, show a sudden sharp decline in diversity, all pointing to this one apocalyptic event. But how do we know this really happened? The answer lies in a single mysterious element: iridium. Rare on Earth but common in asteroids, iridium levels spike dramatically in rock layers across the globe that date to exactly 66 million years ago. That thin, dark line, the Cretaceous-Paleogene boundary, acts like a fingerprint of catastrophe. And beneath the Gulf of Mexico, the buried remains of the Chicxulub crater confirm it. Shocked quartz, glass spherules, and gravitational anomalies all match an impact of unimaginable force. Recent core samples from the crater have even revealed layers of tsunami deposits, suggesting waves over 100 meters high radiated across ancient oceans, battering coastlines for hours after the impact. Some regions experienced earthquakes of magnitude 11 or higher, the largest quakes in Earth's history, while volcanic eruptions may have been triggered globally, adding more ash and carbon dioxide to the sky. The atmosphere became a deadly soup. Acid rain fell, poisoning lakes and soils. Carbon dioxide surged in the long term, causing a greenhouse rebound after the freezing dark. The planet swung violently between extremes, first fire, then ice, then an oppressive, choking heat. And yet, even in this darkest hour, life clung on. Tiny, shrew-like mammals tucked away in burrows and tree trunks emerged as survivors. Crocodiles, turtles, and some birds, descendants of small, feathered dinosaurs, adapted and endured. These remnants would become the seeds of a new age. It's humbling to realize that our own mammalian ancestors likely survived this apocalypse, not because they were dominant, but because they were small, flexible, and hidden. While the mighty Tyrannosaurus rex fell, our tiny rat-sized forebears inherited the Earth. Scientists have even found a fossilized deathbed in North Dakota, known as the Tanis site, where a fish is preserved with molten glass spheres in its gills, evidence it died within minutes of the impact, as seismic waves and raining ejecta arrived in sync. It's one of the rarest glimpses into what might have happened in real time during those horrific first hours. The asteroid didn't just end a world, it reset evolution. Without it, dinosaurs might still rule, and mammals might never have emerged beyond the shadows. It reminds us that life on Earth is not only resilient, but also shaped by random cosmic events. Our very existence, as humans, thinkers, builders, storytellers, is built on the ashes of that extinction. What's even more chilling is that Earth still lives under the same cosmic roulette. Thousands of near-Earth objects roam the void, and while our technology has improved, the skies remain unpredictable. The story of Chicxulub is not just a tale of death, it's a warning, a memory, and a mirror into our own future. Because once the world burned, and it can burn again. Chapter 2. Life in the Shadows. In the aftermath of the asteroid impact, the Earth had become a planet almost unrecognizable. The skies were darkened by a thick shroud of dust and soot, blocking the sun and casting the entire globe into an eerie twilight. Forests that once rang with the calls of dinosaurs now stood silent, their canopies burned or stripped bare. Fires had raged for months. Oceans had surged with tsunamis. The food web had collapsed, and with it, nearly all of the planet's dominant life forms. In this harsh, altered world, survival was no longer about strength or size. It was about adaptation. It was about finding shelter, changing behavior, and staying hidden. And in this new world, the age of the small had begun. The survivors of the Cretaceous-Paleogene extinction event were not the magnificent creatures that had once ruled the land, sea, and sky. Instead, they were mostly small-bodied, cold, resilient, generalist species. Crocodiles survived by hunkering down in aquatic environments, capable of slowing their metabolisms and going long periods without food. Some turtles, amphibians, and even a few birds endured by exploiting ecological niches that remained relatively undisturbed. But among the most remarkable survivors were mammals, particularly small, insect-eating ones who had spent most of the Mesozoic era in the shadows of the dinosaurs. These early mammals, often no larger than a rat, had already been quietly evolving in secret. One such mammal, Purgatorius, is thought to be a key player in this story of survival. This tiny arboreal creature lived in trees, feeding on insects and possibly fruits, with flexible ankles and grasping limbs. Such traits not only made it adept at climbing, but also allowed it to shelter in places that were inaccessible to predators or falling debris. In the cold, post-impact world, its small size and omnivorous diet gave it an edge. It could feed on anything it could find: insects, seeds, fungi, or decaying plants. More importantly, mammals like Purgatorius had a few evolutionary advantages that gave them the resilience to weather the crisis. They were warm-blooded and could regulate their body temperature, unlike reptiles, who relied on external heat sources. They reproduced quickly and matured fast, allowing populations to bounce back more easily after mass death events. Their brain-to-body size ratios were increasing, allowing more complex behaviors, adaptability, and learning. Where dinosaurs had relied on size and dominance, mammals thrived through flexibility and stealth. As the years passed and the dust slowly settled from the skies, a strange new world began to emerge. The lush tropical forests of the Cretaceous were gone, replaced by sparse, fern-covered landscapes and fungi-rich woodlands. Fungi, unlike plants, did not require sunlight and proliferated in the decaying biomass left behind. For nearly a decade, this fungal bloom dominated the Earth's surface, creating a surreal, spore-laden ecosystem in which only the most adaptable could survive. And it was here, in this damp, decomposing world, that mammals began to flourish. Their ability to burrow, nest, and hide helped them avoid predators and extreme environmental changes. Fossorial, burrowing lifestyles became critical. Mammals built underground shelters to escape the cold and the chaos. They foraged at night, avoiding predators and conserving energy. Those that could swim, or at least wade through water, found refuge in freshwater ecosystems, which were less affected than terrestrial or marine habitats. Studies suggest that freshwater habitats served as important sanctuaries during this time, preserving both food and stability. The first few thousand years after the impact were not about progress. They were about survival. But even in the wake of disaster, life pushes forward. Slowly, ecosystems began to rebuild. Ferns were eventually replaced by pioneering plant species. Insects rebounded. With fewer predators, the small mammals spread into new territories. They filled the empty ecological niches left by dinosaurs, taking on roles as herbivores, scavengers, insectivores, and omnivores. Natural selection favored the curious, the quick, the adaptable. And in the canopy of the new forests, primates began their slow rise. Small, tree-dwelling mammals with grasping hands and feet, likely descendants of Purgatorius, began to diversify. The ability to navigate the complex, three-dimensional world of trees required excellent balance, depth perception, and coordination, traits that drove the development of larger brains and more complex social behaviors. These early primates, already well-suited for life in the trees, began to explore a range of new adaptations. They communicated more. They formed groups. They raised their young with increasing care. The world remained dangerous. Volcanoes still erupted. The climate was unstable. But evolution thrives under pressure, and mammals rose to the challenge. From the hidden cracks of a ruined planet, the age of mammals had quietly begun, not with a bang, but with a scurry in the dark. The story of humanity does not begin with dominion. It begins with survival, in burrows, in trees, in silence. The mammals that endured the end of the Cretaceous did so not through power, but through patience. They were generalists in a time of crisis, shapeshifters in an age of ruin. And because of them, the future of life on Earth would never again be measured by size alone. In the next chapter of Earth's history, these survivors will rise, evolving into forms the world has never seen. But for now, in this chapter of darkness, they remain hidden, living in the shadows, waiting for the sun to return. Chapter 3: From Ashes to Apes. In the aftermath of the great extinction that ended the reign of the dinosaurs, the Earth was transformed into a vastly different world. The sky had slowly cleared of its ashen veil. The fires that had consumed entire continents were reduced to smoldering embers, and the Earth began to cool and stabilize. Forests cautiously returned, though nothing like the lush canopies of the Cretaceous. The once vibrant and diverse ecosystems were now fragmented and sparse. In this new world, evolution was not just continuing, it was accelerating. Life, having been nearly extinguished, now found itself with room to grow, niches to fill, and a world reshaped by cataclysm. At the heart of this evolutionary renaissance were the mammals, small, warm-blooded creatures who had survived by virtue of their size, adaptability, and dietary flexibility. No longer forced to cower beneath the shadows of towering reptiles, mammals emerged into the light of opportunity, and among them, a group began a journey that would eventually lead to humanity: the primates. For millions of years, mammals had evolved quietly during the Mesozoic era. They were largely nocturnal, avoiding direct competition with the dominant reptiles. But with the extinction of the non-avian dinosaurs, mammals experienced what scientists call an adaptive radiation, a rapid diversification in response to the availability of new ecological niches. Within a few million years, mammals expanded not only in number, but in variety. Some evolved into large herbivores, grazing on the recovering flora. Others became skilled hunters. Some returned to the oceans and eventually evolved into whales, while others adapted to life in the trees. This last group, the arboreal mammals, began to exhibit the earliest traits associated with primates: grasping hands, stereoscopic vision, and enhanced brain development. The Paleocene and Eocene epochs, 66 to 34 million years ago, were critical in shaping the earliest members of the primate lineage. During the Eocene, the Earth experienced a global warming event, and tropical forests expanded across much of the planet, from the equator to the poles. These forests were the perfect environment for early primates to evolve. Fossils from this period reveal creatures like Tailhardina, one of the earliest known true primates. These animals had large eyes suited for nocturnal life, long fingers adapted for grasping, and relatively large brains for their size, suggesting enhanced cognitive abilities. They lived in the trees, foraging for fruit, insects, and leaves, and their anatomy reveals that they were agile climbers, well adapted to navigating the complex three-dimensional environment of the forest canopy. As primates diversified, they gradually split into two major branches: the prosimians, like modern lemurs and tarsiers, and the anthropoids, which would eventually include monkeys, apes, and humans. Fossil discoveries in Asia and Africa reveal that early anthropoids appeared around 40 million years ago. Such creature was Eosimius, a small primate from China that displayed many features linking it to later monkeys and apes. By around 30 million years ago, a key figure in our lineage emerged: Aegyptopithecus. This primate lived in what is now the Fayum Depression of Egypt. It had a mix of monkey-like and ape-like features, including a larger brain, forward-facing eyes, and increased social complexity. Though it still lived in trees and moved on all fours, it represents one of the earliest members of the group that would give rise to apes. As Earth's climate began to shift again during the Oligocene and into the Miocene epoch, global temperatures cooled and tropical forests began to retreat, replaced in many areas by woodlands and grasslands. This environmental change pressured primates to adapt once again. Some remained in the trees, clinging to their arboreal ways. Others began to descend more frequently to the ground, where they encountered new challenges and opportunities. Around 20 million years ago, in East Africa, the genus Proconsal emerged. These were early apes, larger than their monkey relatives, with more flexible shoulders and stronger limbs for climbing. Notably, they lacked tails, a defining trait of modern apes. Proconsal represents a transitional form, bridging the gap between monkeys and the great apes. The Miocene epoch, 23 to 5 million years ago, was a golden age for apes. Fossil evidence reveals a wide variety of ape species spread across Africa, Europe, and Asia. Some were small and gibbon-like, others were larger and more robust. As these apes adapted to their environments, some began to experiment with new forms of locomotion, including knuckle walking and eventually upright walking. These changes laid the anatomical groundwork for bipedalism, the key adaptation that would later define the human lineage. It was during this time that the earliest ancestors of gorillas, chimpanzees, and humans began to diverge from one another. What had begun as a scattered group of small tree dwellers had, over tens of millions of years, evolved into intelligent, socially complex, and physically diverse creatures capable of transforming their environment and shaping their own destiny. From the ashes of the Cretaceous, evolution had crafted a lineage with the potential not only to survive, but to understand survival itself. The stage was now set for the next chapter. The emergence of the first hominins, our direct ancestors, and the long, winding road toward what we would eventually call humanity. Chapter 4. The human spark. As the Miocene epoch waned and the Pliocene began, roughly 5 million years ago, the planet was once again undergoing profound transformation. Tectonic forces reshaped landscapes, forming new mountain ranges and redirecting ocean currents. These geological shifts altered global climates, cooling the earth and drying out the dense forests that once blanketed much of the tropics. In Africa, lush jungles gave way to open woodlands and expanding savannas. This gradual but persistent environmental pressure forced a crucial evolutionary fork in the road for many primate species, particularly those living in East Africa. Among these primates, a new kind of creature began to emerge, one that would walk upright, craft tools, form cultures, and eventually look back at the stars and ask where it came from. This was the beginning of the human story. The earliest known hominin, a member of the human lineage, is believed to be Sahelanthropus chadensis, discovered in Chad and dating back around 7 million years. Though it still bore many ape-like features, including a small brain, its skull suggests an upright posture, a key trait in human evolution. Walking on two legs, or bipedalism, was a revolutionary adaptation. It freed the hands for carrying food and crafting tools, conserved energy on the open plains, and allowed early humans to see over tall grass and spot predators from a distance. Over time, more bipedal hominins appeared, such as Australopithecus afarensis, best known from the famous skeleton Lucy. These early humans were still small, averaging only 3 to 4 feet in height. but they had begun to master their landscapes in new ways. By around 2.5 million years ago, the genus Homo had emerged, with species like Homo habilis showing clear evidence of tool use. Stone tools marked a dramatic leap forward, enabling early humans to butcher animals, process plants, and defend themselves. Brain size began to increase, and with it came more advanced cognitive abilities. Social structures grew more complex, and early humans began to share food, care for the injured, and perhaps even communicate in rudimentary language. Fire, though not fully controlled until much later, became a source of warmth, protection, and possibility. Then came Homo erectus, the first human species to leave Africa and spread across Asia and Europe. These early humans stood taller, made more sophisticated tools, and possibly used fire regularly. Their migrations laid the groundwork for global colonization. Over the next million years, human evolution continued, producing diverse species like Homo heidelbergensis, Homo floresiensis, and Homo neanderthalensis, each adapting uniquely to their environments. Neanderthals, for instance, thrived in Ice Age Europe, developing large brains, strong bodies, and even symbolic behavior such as burial rituals. And then, roughly 300,000 years ago, in the cradle of Africa, emerged Homo sapiens. Anatomically modern humans, with high foreheads, rounded skulls, and the cognitive hardware for language, imagination, and abstract thought. What set Homo sapiens apart wasn't just intelligence, it was creativity. Art, music, myths, and complex societies began to appear. Humans began to shape not just their tools, but their entire environment. They domesticated plants and animals, formed communities, and eventually gave rise to civilization. The spark that made us human was not a single mutation or event. It was a slow accumulation of adaptations, driven by environmental challenges, social cooperation, and the ever-present need to survive and adapt. Our ancestors survived volcanic winters, changing climates, predators, and even competition from other human species. But they did more than survive. They endured, they learned, and they remembered. From a tiny, warm-blooded creature in the shadows of dinosaurs to a species capable of landing robots on Mars, the journey has been nothing short of miraculous. And yet, it all traces back to that one apocalyptic moment 66 million years ago. If the asteroid hadn't struck, if the dinosaurs had remained dominant, the lineage that would become us might have remained small, obscure, or never evolved at all. The destruction of one world became the seedbed for another. The spark of humanity was not born in triumph, it was born in survival. That is our inheritance. And that is our story. Chapter 5. The path diverges even as early humans were learning to tame fire, shape tools, and form small social groups. They were not alone. For much of our evolutionary journey, we shared the planet with other human species, some close cousins, others more distant relatives. In caves and forests across Africa, Europe, and Asia, multiple types of humans once walked side by side. Some had massive jaws and powerful builds, like Paranthropus. Others, like the Neanderthals, Homo neanderthalensis, were intelligent and culturally rich, capable of art, burial, and even symbolic thought. Then there were the enigmatic Denisovans, known mostly through fragments of bone and genetic traces. For hundreds of thousands of years, these various hominins thrived in their respective regions, adapting to local conditions and evolving independently. But today, only one lineage remains: us. The mystery that haunts paleoanthropology is not just how we evolved, but why we survived when all the others vanished. The fossil record shows that Homo sapiens emerged in Africa around 300,000 years ago. For tens of thousands of years, we coexisted and even interbred with other hominin species. Genetic evidence confirms that modern non-African humans carry traces of Neanderthal DNA, while some populations in Oceania bear Denisovan genes. This means the story of humanity is not linear. It is a web of intermingling lineages, a tapestry woven from ancient encounters. So why, then, did we become the last branch left standing? One possibility lies in our cognitive edge. While Neanderthals had large brains, sometimes even larger than ours, Homo sapiens seems to have developed more advanced symbolic thinking, language capabilities, and social complexity. The development of language may have been humanity's true superpower. It allowed not only the sharing of practical knowledge, like how to craft better tools or track animals, but also the transmission of abstract ideas, myths, and collective memory. These abilities enabled larger, more cohesive groups to form, enhancing cooperation and resilience in the face of environmental stress. Another factor may have been adaptability. Homo sapiens spread further and faster than any other hominin, occupying environments ranging from Arctic tundra to dense rainforests. We crafted specialized tools for hunting, fishing, and sowing. We created shelters suited to each climate, and we learned to exploit a wide variety of food sources. While some hominins may have been tied to specific environments or limited diets, our ancestors became generalists, the kind of species most likely to weather change. And there was plenty of change to weather. During the Pleistocene, Earth's climate fluctuated wildly between glacial and interglacial periods. Entire ecosystems shifted in the span of just a few centuries. In Europe, advancing ice sheets pushed Neanderthal populations south. In Asia, changing rainfall patterns fragmented Denisovan habitats. In this dynamic landscape, flexibility was key. Some researchers propose that our ability to form trade networks, share resources between groups, and innovate rapidly gave Homo sapiens a crucial advantage. When food grew scarce or climates shifted, we adapted not just physically, but culturally. Yet for all our advantages, our coexistence with other humans was not always peaceful. Archaeological evidence suggests competition, and possibly conflict, may have played a role in the extinction of Neanderthals and other hominins. Whether through direct violence, competition for resources, or simply out-surviving them in lean times, Homo sapiens gradually became the dominant human species. By around 40,000 years ago, Neanderthals were gone. The Denisovans disappeared. Other hominin branches, like Homo floresiensis, the so-called hobbits of Indonesia, and Homo luzonensis in the Philippines, also vanished into the shadows of history. But these disappearances raise a deeper, more philosophical question. What if they had survived? What if we lived in a world shared with multiple intelligent human species, each with their own cultures, languages, and histories? Would we have cooperated or clashed? Would civilization have evolved differently? These questions stir the imagination and remind us of how contingent our history truly is. In the end, the path diverged. From a family tree once full of branches, only one now reaches into the future. But the others are not truly gone. They live on in our DNA, in our myths, and in our memory. Their story is our story. And in every human face today, there are echoes of the ancient others we once walked beside. The legacy of survival from the ashes of planetary devastation to the heights of modern civilization. The story of humanity is one of improbable endurance and extraordinary transformation. What began as a desperate grasp for survival in a ruined world eventually became a triumph of adaptability, intelligence, and resilience. The asteroid that ended the reign of the dinosaurs was not the end of life. It was a brutal reset, a cosmic recalibration that allowed new life to rise in forms unimaginable to the species that came before. And from that reset came us, not as conquerors from the start, but as survivors, shaped by scarcity, honed by adversity, and made stronger by every generation that learned to endure. We were never destined to rise. The earliest mammals were insignificant in a world of giants, their lives defined by fear and obscurity. Yet they carried within them a powerful advantage: the ability to change. Through millions of years, they evolved into creatures with sharper senses, greater curiosity, and ever-growing brains. They took to the trees, then to the plains. They learned to walk upright, to share knowledge, to dream. Our lineage passed through fire and ice, famine and flood, extinction and rebirth. It was not one species that brought us here. It was a mosaic of ancestors, known and unknown, each contributing to the grand experiment of human life. The legacy of our survival is not merely written in fossils or DNA. It is written in the stars we gaze upon, the art we create, the questions we ask, and the futures we imagine. We are the children of catastrophe, but also the architects of wonder. Every heartbeat today echoes with the rhythm of that first mammal that scurried through a burning forest. Every thought a continuation of minds shaped by ancient struggle. And as we now face our own global challenges, climate change, extinction, and the possibility of cosmic threats, we would do well to remember that we are here because those who came before us adapted. They endured. They evolved. The story of humanity is not over, but the prologue is complete. And it began, as all great epics do, not in triumph, but in survival.